Hello students, welcome back to my YouTube channel Mathematical Lens by Namita. I'm going to introduce a new playlist specifically for class 8 students for maths, and I'll cover all the chapters of NCERT textbook. All important concepts of that particular chapter will be covered with explanation of examples for each concept. So the name of this playlist is Revision in a Flash. Right? So with this, I hope you will be able to revise the chapter before exams and it will be easier for you to attempt the exams. Let us start with chapter 1, rational numbers. Right? First, we'll look at the Venn diagram which is given over here. So you have already learned about natural numbers. Natural numbers or the counting numbers, they start from 1, 2, 3, 4, 5, 6 and so on. They go on infinitely. Next set of numbers are whole numbers. They start from 0, 1, 2, 3, 4. They go endlessly infinitely. Then comes the next set of integers are integers which include 0, positive integers and negative integers. Okay. Now the new set of numbers which we are going to learn are the fractional numbers which are included in the rational numbers. So fractional numbers, positive, negative, decimal numbers, they are all included in rational numbers. So let us understand what are rational numbers in detail. Now rational numbers are the numbers which can be expressed in the form of P upon Q. Right? So P upon Q where Q is not equal to 0. That is the most important part which you need to remember. Both P and Q are integers but Q cannot be 0. Right? Because any number divided by 0 is undefined. Right? So you can see certain examples given over here like 1.5, 5.212, minus 4 upon 3. These are all included in rational numbers. Right? But just see this number 0.9 and there is a bar over it. Now what does this mean? So this means that 9 is repeating 0.9999. It will go on repeating. So you can't write 9 so many times. So that's why this bar is shown. So all decimal numbers which are repeating, non-terminating but repeating, they are included as rational numbers. And this 5.212, this is a decimal number, but it's a terminating decimal number. Terminating means that has infinite number of digits. Like here, 5.212. So it stops at 2. So it has finite number of digits after the decimal point. The terminate means it ends. It ends somewhere. Right? So 5.212. These are also rational numbers. 0.99 means non-terminating, but if they are repeating, then they are also rational numbers. See, fractional numbers, positive and negative, are included. But what kind of decimal numbers are included in rational number? That is most important for you to remember. So all terminating and non-terminating repeating numbers, they are included in rational numbers. Now, what does this diagram depict? You need to remember that all natural numbers are included in rational numbers. All whole numbers are also rational numbers. All integers are also rational numbers. That's why the bigger circle is of rational numbers and these are included in it. So this is most important. You need to remember that all these types of numbers are also rational numbers. Now, one more important thing which you need to understand is about the fractional number. There are like two types of fractional number. You can say positive and negative. Now, which are positive rational numbers or which are positive fractional numbers? Either both numerator and denominator are positive or both are negative, because negative will be cancelled, so they become positive. So if both numerator and denominator are either positive or both are negative, then they are positive rational numbers. And if the numerator is positive and denominator is negative, or the numerator is negative and denominator is positive, then that's the negative rational number. Remember some properties, revise some properties of rational numbers. These properties you have already learned for whole numbers, natural numbers and integers earlier. But you should know these properties for rational numbers. So let us first see the closure property. right? So rational numbers are closed under addition, subtraction, multiplication, but not under division. Now what is closure property means? If you add two rational numbers, the answer which you will get, the sum which you will get will also be a rational number. Similarly, if you subtract two rational numbers, the answer will also be a rational number. Same thing is for multiplication. But it is not necessary for division that if you divide rational numbers, two rational numbers, you get a rational number. That's why it is not closed for division. Second important property is commutative. We can remember commutative and associative together. Now commutative property says that you can add two numbers in any order. The answer remains the same. Now, and similarly here associative property, it is more than two numbers, right? It will have more than two numbers, 3, 4 numbers. So again, you can change the order of addition, right, for rational numbers. So the operation like commutative and the operation addition and multiplication, both are commutative and associative. You can see for addition it is tick mark and for multiplication also it is tick mark. So addition and multiplication both are commutative and associative for rational numbers, but not subtraction and division. So let us see some more properties of rational numbers. Some of them you already know, you have learned in lower classes. So what is one is additive identity. The first one is additive identity. Additive identity is 0, means you add 0 to any number, the answer is the same number. Then what is additive inverse? Additive inverse is the same number with a different sign. Like if it is 3, if it is plus 3, the additive inverse is minus 3. If it is minus 3, the additive inverse will be plus 3. Then multiplicative identity is 1. That is, you multiply any number by 1, you get the same number. Then multiplicative inverse. Multiplicative inverse is also known as reciprocal. Now here we just change the position of numerator and denominator. So here it is, if it is 7, it becomes 1 upon 7. 7 means 7 upon 1, so reciprocal will be 1 upon 7. Suppose it is 4 upon 8, so the reciprocal will be 8 upon 4. Multiplication by 0, you multiply any number by 0, the answer is 0. Division by 1, you divide any number by 1, the answer will be the same number. And last but not the least, very important, division by 0. As we saw earlier also, division by 0 is not possible, it is not defined. So these are some important properties which you need to remember. And now one by one we'll take some examples of the application of these properties and the different types of sums which are important for this chapter. So let us see an example where we apply the properties which we have just learned in some sums, right? We always learn properties and we wonder what is the use of these properties. So we'll understand how the use of these properties will make your calculation easier. Okay, so let us see this example. Now you can see that it is addition of these fractional numbers. You need to find out the sum of these fractional numbers. Now, what are we supposed to do? Actually, we are supposed to find out the LCM of all 4. But if you look at the denominators, if you find out the LCM of all 4, it will be a very big number and it will be time consuming. But if you look at the denominators and find out something common in them and club them, right? Because clubbing them will make your work easier. So if you see here 7, 11, 21 and 22. So 7 and 21. Why 7 and 21? They have 21 is a multiple of 7. Right? So we take these two together. So finding LCM would be easier. So we are applying both commutative and associative property of addition. And we see the other two numbers 11 and 22, the denominators. We need to focus on denominators. So here also 22 is a multiple of 11. Right? Now when you see the multiple, you already know that to find out LCM, if 1 is the multiple of the other number, the LCM will be the multiple. That is the bigger number, 27. 7 3s are 21, so 21 is the LCM. Right? So simply here 7 3s are 21, so we'll multiply this 3 with the other 3 which is already given, so 3 3s are 9, plus here already the denominator is 21, so we write minus 8. Now let us look at the other two. Here 11 and 22. So 22 will be the LCM because 22 is a multiple of 11. 11 2s are 22. So we multiply this by 2. So 6 2s are 12. There is minus sign. So we write minus 12. Plus 5 will remain as it is because the denominator is already 22. Right? Now it has become a bit easier if you see. Now 9 minus 8 plus minus will be minus. If you want to increase one step to understand the calculation, you can do that. I'm writing the second one as it is. So this will be 9 minus 8 is 1 upon 21 plus minus 12 plus 5 will be different sign means subtraction and sign of greater. So minus 7 upon 22. Okay. Now you need to just find out LCM of 21 and 22. Now they do not have any common factor. So their product will be their LCM. So 21 into 22 gives you 462. And if both are co-primes, 21 and 22 do not have any common factor, so they both are co-primes, so the LCM would be their product. So you need to just multiply and do cross multiplication. So 22 will be multiplied with 1. So 22 into 1 is 22 and 21 will be multiplied with 7. Right? So it is minus 147. Okay. So 22 minus 147 plus minus will be minus. So we subtract and put the sign of greater. So which is 125 upon 462. So your answer is minus 125 upon 462. So which property did we apply over here? They are commutative and associative properties. Okay. Let us see another example now. So now let us see another example where we apply the properties. Okay. So here we are finding the product of all these rational numbers. In product, though you can cancel numbers anywhere like numerator and denominator, but still if we club them, it makes our work easier. So let us see 4 upon 5. Try to identify the common factors in numerator and denominator. We'll take 15 upon 16 along with this and put a bracket. So you can see 4 and 16 have a common factor as well as 5 and 15. Similarly, what is left is 3 upon 7 and minus 14 upon 9. Here also 3 and 9, 7 and 14, they have common factors, right? So now if we try to cancel, 4 ones are, it is minus 1, so I write minus 4, 4s are 16. Then 5 ones are, 5 3s are, right? So this becomes simpler. Now if we cancel here, 3 ones are 3, 3s are 9. Then we can cancel 7 and 14. So 7 ones are 7 2s are. Minus 2 will be there because it is minus 14. Don't forget this minus sign because this is a very common mistake which children do and get a wrong ones. So now what are we left with? If we see here numerator, 3 ones are 3, minus sign, so minus 3. Here 4 ones are 4 into. What is left over here? 1 into minus 2 is minus 2 and 3 ones are 3, right? Now still it is a multiplication sign, so you can cancel the numerators and denominators. So let us see what can we cancel. So if you see 3 and 3, so both ones are, but here it is minus 1, so we write minus 1. 2 ones are, 2 2s are 4, right? Now this minus minus would become plus. Here it is minus 1. So minus 1 into minus 1 becomes plus 1. So 1 and 2 ones are 2. So your answer is 1 upon 2. Right? So again here we applied commutative and associative property of multiplication. Now let us see another example of distributive property. Again, there are two terms. This is one term. I told you, you identify the terms. This is one term and this is another term. Okay. So, just see what is common in both the terms. So, minus 3 upon 4 is common. So, we write it outside the bracket and in the curly bracket we write down whatever fractions are left. So, here 3 upon 4 is common and 2 upon 3 we have written inside. And here also minus 3 upon 4 is common, so that goes outside. And we write minus 5 upon 6 which is left. Okay. So we leave this as it is and then we solve the bracket first. So here the LCM of 3 and 6 will be 6. Right. I told you earlier also that 6 is a multiple of 3. So 6 will be the LCM. Now 3 2s are 6. So we will multiply 2 with 2. Okay. This is for understanding. You can do it mentally. So 2 2s are 4. And here already the LCM is 6 and denominator is 6. So we write minus 5 as it is. So what is left is minus 3 upon 4. Now 4 minus 5 will be minus 1. Plus minus is minus. So we subtract and put the sign of greater. I am just repeating the integers, addition of integers and subtraction of integers. Now it is multiplication sign. So you can cancel. What can you cancel over here? Minus minus will be cancelled. 3 1s are 3 2s are. What is left is 1 upon 8. So your answer is 1 upon 8. So you should apply the properties and make your calculations easy. Now we'll see this type of questions where you are supposed to find out rational numbers between any two given rational numbers. You may be asked to find out 2, 3, 5 rational numbers, right? So what are we supposed to do? 2 and 3, the numbers are given. So we can multiply this number. You need to find out actually equivalent fractions. So you can multiply this by 10, 10 upon 10. If you are multiplying by 10, to make it equivalent, you also need to divide by 10. So 10 upon 10. And 3 also you multiply by 10 upon 10. So this becomes 20 upon 10 and this becomes 30 upon 10, right? Now you can write any two numbers between 20 and 30 with the denominator. Don't forget to write the denominator. So after 20 upon 10, there is 21 upon 10, 22 upon 10, 23 upon 10, 24 upon 10, right? So you can write as many, like here between 20 and 30, you will get at least 9. So you can write all those rational numbers or whatever rational numbers are asked between them. Why I have chosen 10? Because multiplying by 10 is easy. You can multiply it by 5, you can multiply it by 100, 1000, you can multiply it by any number. Okay, but whichever number you choose, you have to multiply and divide by the same number to get the equivalent fraction. And while writing the answers, don't forget to write the denominator. Don't just write 21, 22, 23. So this shows that there are many, you can say infinite rational numbers between any two rational numbers. Right? Even if it is a fractional number, two fractional numbers are given here instead of whole numbers. There also you can get as many as you want. Instead of 10, if you multiply by 100, you will get more numbers. Right? So this is the way you can find out rational numbers between two rational numbers. Now this is another important question. Standard form or reduced form. So you may be asked to find a standard form or reduced form of any given fractional number or a rational number, like suppose it is 24 upon 36. So standard form or reduced form means you should reduce it, you should cancel the numbers till you get a reduced form where there is no common factor left between the numerator and the denominator. Right? So we will reduce it. You can easily see that 24 and 36 are divisible by 12. So 12 2s are 24, 12 3s are 36. The answer is minus 2 upon 3. You can even strike off with 2, 3, that is common. Not necessary that you directly strike off with 12, right? But it's very easy if you find out HCF and strike off with that, right? So this is the way you will find out the standard form or the reduced form. Now representing a rational number on a number line. Here it is minus 3 upon 5, right? So we will take it on the left side of 0. So suppose we take it this as 0. So see the denominator. So that means you have to divide it into 5 equal parts. The number between 0 and minus 1, it should be divided into 5 equal parts. Or you can simply start from 1. It is negative, so we are starting going on the left hand side. So this will represent minus 1 upon 5. This will represent minus 2 upon 5. So just keep on writing in sequence. 3 upon 5, minus 4 upon 5, and minus 5 upon 5. Minus 5 upon 5 is equal to minus 1. So where is our answer? Minus 3 upon 5. So this is the place where minus 3 is. You can highlight that. So this is how we represent rational numbers on the number line. If it is positive, you will go on the right side. If it is negative, you will go on the left side. And just see the denominator and start from 1. If it is negative, minus 1 upon whatever is the denominator. If it is positive, 1 upon, suppose it is 6, 1 upon 6, 2 upon 6, like that. You go on writing, right? Whether it is a proper or an improper fraction. So I hope you were able to understand and revise chapter number 1, rational numbers of class 8 NCRT. And thank you for watching the video. If you like the video, click the button of like, kindly subscribe and share with others. Thank you. Bye bye for now.